Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Pointing at the Void by Alazugo. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have little killers, where numbers outside the grid are the sum of the digits pointed to along the indicated diagonal. Digits are allowed to repeat along those diagonals as normally allowed by the other rules. So, for example, along this diagonal must be 3 digits that add up to 15. Along this diagonal must be 4 digits adding up to 14. Along this diagonal must be 7 digits adding up to 36. Along this diagonal must be 9 digits, we can get hopefully, adding up to 54. And that's an example of how little killers work. We also have arrows, where the digits in an arrow circle is equal to the sum of the digits on the attached arrow, and digits are allowed to repeat along the arrows as normally allowed by other rules. So, for example, if this were, say, let's say this was 3 and this was 5, and this would have to be 8 along this arrow, because these two digits must sum up to the digit that's in the connected circle. And finally, we have a even, where a digit in a gray square must be even. So these digits must be even. Anyways, those are all the rules. If you like play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. The sum of these digits on the arrow is equal to the digit on the circle. Same with this. And so therefore, these 4 digits as a whole must add up to an even sum, right? Because these digits add up to whatever the digit in the circle is. So as a total, they must add up to 2 times the digit in the circle. Same with this one. So therefore, this is an even sum. This is an even sum, which means for the whole diagonal to be even, this last digit here must be even. And also these are even. We have something similar along this diagonal and this diagonal, right? We have digits along the arrow, sum up to this digit there. So this is equal to 2 times the digit in the circle. Same with this, same with this, same with this. So that means this must be even, this must be even, and this must be even. Well, we have 4 evens in the box 5, which eliminates evens in the rest of the box, so this has to be odd here. This is an even sum, even sum. So this... The diagonal here adds up to 54. This is at most 4, 6, and 8, which adds up to 18. These digits, at most, can only add up to 18 because the sum of a digit times 2, at most, is 9 times 2, which is 18. So since the maximum here is equal to the total sum here, this must equal the maximum. So this is 4, 6, 8. This has to be 9, and that's 9 there. And then this must be 2, obviously. Because 18 plus 18 plus 18 is 54. 18 times 3, right? So that's the maximum that this diagonal can be for everything along this diagonal. So therefore, this is 9, this is 9. 9 cannot be any of these. 9 cannot be on an arrow, because if it sums up with another digit to add up to a single digit, because 9 is the largest digit, so 9 has to be one of these two. 9 cannot be here and here. It cannot be on the arrow. Where is it in box 1? It has to be here. So that's 9. That means 9 has to be one of these two digits there. It has to be one of those two digits there. Cannot be on the arrow. So it's one of those 3 digits there. It's pretty broad here. Pretty broad here. Okay. Okay, what does that mean? So this is 8 at most and 8 at most there. That would mean, okay, so what can these numbers go down to? Well, first of all, they can be down to 4, technically. But even if we had 4 along this diagonal, that would be a value of 8 for this set. 8 plus 8 is 16, but then this digit would have to be 20, so that's not possible. So these two digits, this can be 8 at most here. So 36 minus 8 is 28. 28 divided by 2 is 14. So these two digits must add up to at least 14. And there's no 9. So it has to be 6, 7, or 8 here, and 6, 7, or 8 there. What about, this is similar, right? This is 4, 6, 8 at most. So 8 at most here means the sum of these can be at minimum 28. So again, we have 6, 7, 8 there. One of them does have to be a 6, though, interestingly enough. This is 6, 7, or 8. So that means these two digits at most can add up to 7. So we'll have 2, 4, or 6 there. We cannot have 6 here because 6 and 2 would already add up to 8. So this is 1 through 5 there. This can be 5 at most here, because 5 plus 1 and 2 could add up to 8. So this is 1 through 5. Same with this. This could be 1 through 5. No 2, obviously. No 2 or 4. This is 1, 3, or 5 here. Along this diagonal is 14. But we already have a 9 here. Can this be non-2? If we have 9 and 4, that's already 13, plus 1 and 1 is 15 already, which is too small, or too big. So this has to be 9 and 2. Can this be 3? 9, 2, and 3 already adds up to 14, so no, this can't be 2 because of 2 in the column. So this must be 1 here. So we have 1, 9, 2, and this could be, this is 12 already. So then this must be 2 over here. So this is an even, which means 2 in row 6 has to be here because it can't be here because of 2's in the boxes. 2 has to be there also. 1 can no longer be here. This can't be 5 anymore because if this is 5, you cannot have 1 and 2 anymore here along this arrow. So this must be 3 here. That eliminates 3 in the rest of the row. This is at least 1 and 3. It cannot be 2 and 3. It could be 1 and 4 or 1 and 3. So we're guaranteed a 1 along this diagonal. And this adds up to 7 or 8. We don't have any restrictions here, though. Okay. One can't be here, one can't be here. Okay. So these diagonals add up to 72. Actually, let's do all 3 of these. Because all 3 of these are in the same box. All 3 of these are in the same box. And all 3 of these are in the same box. So along these diagonals, we have really restrictive things here, here, and here. 36 plus 36 is 72, plus 30 is 102. We know this is 18. So 102 minus 18 is, so it's almost 20. That's 84. 84 divided by 2 is 21. And we know 9 cannot be on any of these circles. So this has to be a 6, 7, 8 triplet in box 1 and box 9. That eliminates 6, 7, 8 in the rest of the box. So where's 5 in box 1? 5 can only be here. Where is... This is an even digit, so it has to be a 4. This is obviously odd. We have an odd here. These are odd. This cannot be 1 and 4. It's 1, 3 as a pair, which eliminates 1 and... which plus 3 adds up to 7. So this is 7 here, no 7 here, no 7 here. This is 6 or 8 here. So this is odd. These are odd. These have to be even. We have a 6, 7, 8 triplet in box 9, so the rest of the digits are 1 through 5. And then these could be 9 here. Okay. If this is 6, it cannot be 1 and 5. It would have to be 2, 4 as a pair, but this digit cannot be 2 and 4 because of 2 in the row. Sorry, 2 in the column and 4 in the row. So this cannot be 6. This must be 8. No 1, 7 here because of 1 in the box. It could be either 2, 6, or 3, 5 with those as the possibilities. 8 eliminates 8 here, so it's 6. That cannot be the sum of 2 and 4. It must be 1 and 5. And 5 eliminates 5 here, so that's 1, that's 5. Those are both odd. 1 eliminates 1 here, so it's 3, which makes this 1. 2 eliminates 2 here, so it's 3 and 5. This adds up to 15. And we know this is 6, 7 here at minimum. And this is 2 at minimum, which adds up to the actual amount, which is 15. So this must be 2, and this must be 6, 7 as a pair, which forces this to be 8, which eliminates 2 in the rest of the box. To add up to 8, it has to be 2, 1, and 5. If this is 2 and 1, that's 5. If this is 2 and 5, that's 1. Okay, so 2 cannot be here. This adds up to 6 or 7. So we know this is 8. This is 7. 7 plus 8 is 30. Sorry, 15 times 2 is 30. 36 minus 30 is 6. So this is 6. No 6 here, no 6 here. To add up to 36. What else do we have? Okay, sum of these digits. No 1 and 8 here because of ones in the column. No 2 here. This could be 2 and 7 though. It could be 3, 6. No 5 here because of 5's in the column. Where are 1s and 5 in column 1? Can't be here because of 1 and 5 in the box, so this must be a 1-5 pair, which forces this to be a 3-8 pair here in column 1. We have a 1-5 pair in row 7, which eliminates 1 and 5 in the rest of the row. How about this? Okay, remaining digits in row 1. We have 2, 3, 4, 6. 3 cannot be here because of 3 in the box. 6 can't be here because of 6 in the column. 2 eliminates 2 from being there. How to add up to 9 here? You could have 1 here, 8 here. No 2 here, no 2 here. So no 2, 7, no 3 here, no 3 here because of 3's in the rows. And 4 and 5 doesn't work because this 4-5 pair eliminates that from being 4, 5. So this has to be 1, which makes that 8. 1 eliminates 1 in the rest of the column. Okay. So 8 times 2 is 16. 36 minus 16 is 20. 20 minus 8 would add up to 12, and that's 6 times 2. 20 minus 4 is 16, which is 8 times 2, but this can't be 8 times 2. So therefore, this must be 8 here, and this must be 6 to have that add up correctly. Right? 6 plus 8 is 14 times 2 is 28, plus 8 is 36, and then that would force us to be 4 and 7. 6 plus 7 is 13 times 2 is 26, plus 4 is 30. So this cannot be 2 and 4 because 2 eliminates 2 from being here and 2 eliminates 2 from being here. So this must be 1 and 5, and this can't be 1 because of 1 in the column. So that's 5, which makes this 1, which makes that 5, which makes that 1. To add up to 7, we have 1, 6, 2, 5, and 3, 4. No 6 here, so no 1 there. No 3 here, so no 4 here. No 2 here, so no 5 there. So those are all still possible. 5 eliminates 5 here, so that's 1 and 5. 1 eliminates 1 in the rest of the row, so this can't be 1, which means this can't be 6. 5 eliminates 5 here, so this is 3 and 4 to add up to 7. That eliminates 3 and 5 in the rest of the row. So where's the 3 in box 9? Must be one of these two digits, which eliminates 3 in the rest of the column. So where is 3 in row 1? It has to be here. So that's 3. That means 3 has to be one of these digits here. This is 5, 7, 9 as a triplet. 5 can't be here because of 5 in the row. So 5 in box 5 has to be one of these. 5 eliminates 5 here, so this must be 5 here. Okay. Where is the 5 in row 9? Cannot be here because of 5 in the box. Can't be here because of 5 in the box. Can't be here because of 5 in the column. So 5 has to be there. We're given 8 5s now, so we know where the last 5 has to be. It has to be there. Okay, remaining digits of box 4. We have 4, 6, 7, and 9. 4 cannot be here because of 4 in the row. 9 can't be here because of 9 in the column, so 9 has to be one of those two. Where is 8 in column 2? Can't be here because of 8 in the box. Can't be here because of the 3A pair in the box. Can't be here because of 8 in the row. Can't be here because it adds up to 9, but it can only add up to 9 with 1, which cannot be there because of 1 in the box. So 8 has to be there. Okay. The remaining stuff is just normal Sudoku. So let's continue. Row 3. Remaining digits are 4, 7, 9. Obviously, 9 cannot be here because of 9 in the box. 4 can't be here because of 4 in the column. 4 eliminates 4 here, so that's 2, which eliminates 2 in the rest of the row. Okay. Remaining digits of row 4. Actually, let's do row 2. We have 2, 6, 7, 8. No 2 here because of 2 in the box. No 6 here because of 6 in the column. No 8 here because of 8 in the column. So where is a 2 in column 6? Cannot be here because of 2 is in the boxes. These are filled out, so 2 has to be here. That eliminates 2 from being here, so this is 3 and 6, adding up to 9. That means where's 2 in column 3? It can only be here. Don't have enough information there, though. We do have a 6, 7, 9 triplet in row 6, which eliminates 6, 7, 9 in the rest of the row. 6 also eliminates 6 there. That means we are left with 2, 3, and 8 in row 6. And this can't be 3 or 8 because of 3 or 8 in the column. So that leaves this as a 2, which means this can't be 2, cannot be 8 because of 8 in the column. So this must be 3, which makes this 8, which makes that 3. 2 eliminates 2 from here because of 2 in the column. 1 eliminates 1 from here because of 1 in the column. 7 eliminates 7 here, so it's 6. 6 eliminates 6 here, so it's 7. 7 eliminates 7 here, so it's 8, which makes this a 2. 6 eliminates 6 here, so it's 4, which makes this 7. 4 eliminates 4 here, so it's 6. 7 eliminates 7 here, so it's 9. 7 and 9 eliminates 7 and 9 here, so it's 4. 7 eliminates 7 here, so it's 9, which makes a 7. 7 eliminates 7 here, so it's 6 and 9 there. This becomes a 4, 7 pair here. Interesting. Well, remaining digits in column 2 can only be 4 or 7, and this can't be 7 because of 7 in the row. So this is 4, which makes this 7, which makes that 4, which makes this a 7. 4 and 5 eliminate 4 and 5 here, so it's 3. 3 and 4 eliminate 3 and 4 here, so it's 9, which makes this 4, which makes that 1. Remaining digits, then. We have 8 ones. We know where the last one has to be. It's there. I think we already have 9 twos. We do. 3s, we have 9 threes. We have 8 fours, so the last 4 is here. We have 9 fives. We have 8 sixes, the last 6 is here. We have 8 sevens, the last 7. Actually, we have 7 sevens, but the 7 in row 4 cannot be here because of 7s in the column, so 7 has to be there. And we have 8 sevens, so that requires the last 7 to be there. 8s in row 5. 8 has to be here. That gives us 8 eights, so the last 8 is there, which means we're missing a 6. How did I skip 6? We have 8 sixes, the last 6 is there. That means the remaining digits are 9. And that's a solution. Yeah, fairly straightforward, I feel. There were really restrictive limitations with the little killers. So that was interesting. The key here was basically figuring out that these three diagonals were really restricted because of the digits in the circles and the digits along this diagonal here. So that was pretty restrictive there. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.